In terms of the properties, we have the physical appearance. It is hard and brittle, and it can conduct electricity in molten or aqueous state. Okay, and lastly, it is dissolved in water, ataupun it can be solubilized in water. Okay, all right. In terms of lattice energy, we have two factors that can affect the lattice energy. So lattice energy, it is a measurement. Okay, it is a measurement of how strong the ionic bond is. Okay, all right. So there are two factors that can affect the lattice energy. One is the what we
Ionic
call
size.
yes, ionic size. The other one would be
Ionic charge.
yes, okay, ionic charge. Okay, all right. So make sure that's all for ionic bond. Okay, so make sure that you cover all of that. Okay, so we have checkpoint. So checkpoint 3, let's have Farah. Farah, can we hear your answer?
Okay, my answer is for first one is potassium chloride.
Okay, sekejap
And
ya. Okay, wait a second. Why is it not? Okay, maybe saya kena. Alright, arrange the following. Padan nak pasang. Okay. Arrange the following ionic compounds in order of increasing magnitude of lattice energy. Meaning that we should start from the lowest, okay, from the smallest to the highest. Okay, alright, yes, Farah.
my answer is KCl,
KCl would be the start, followed by
KBr,
KBr, and then
SRO,
SRO, next,
and CaO.
and CaO. Okay, all right. So this is based on increasing lattice energy. Okay, all right. So let's check the answer. KCl, KBr, SRO, and CaO. Okay, all right. Yep, this is the answer. Okay, so we have KBr. Sorry.
KBR first, madam.
So it should be KBr, KCl, SRO, and CaO. Okay, let's look at Farah's answer just now. So Farah start with KCl instead of KBr. Okay, all right. So normally this kind of question, the marks allocated will be 1 mark only. Kalau you salah satu, that means everything will be wrong lah. So there's there's no mark for this answer. Okay, even though dia salah satu je, the rest are all correct. Okay, but there's no mark. Okay, kalau dia 2 markah, that means adalah something that we are considering. Tapi if there is this question is allocated with 1 mark only, that means there's no mark. If you get any of this arrangement, salah. Okay, alright. So it should be KBr. Okay, so this should be your answer. You kena separatekan dulu. Okay, KBr, KCl, both of them are +1 and -1. +1 and -1. Okay. On the other hand, this one +2, -2, +2, -2. Okay. All right. So once we have separated that, then only we go for each one of them. Okay. In terms of this, we cannot compare them based on the charge. Kita tak boleh compare because they have the same charge. Okay, so in terms, because they come from the same group, that means we have to go down the group. We have to compare in terms of size. Okay, so Br is located below Cl in the periodic table ataupun in the group. Okay, so that means Br has larger in size compared to KCl. Kalau larger in size, that means the attraction is weaker. Okay, weaker means less energy is needed to break the attraction. Okay, therefore KBr should have lower lattice energy followed by KCl. Okay, alright. So CaO and SRO also have the same explanation. Calcium and strontium, they come from the same group, which is group 2. Okay, strontium is located below calcium. That means strontium has bigger in size. Okay, bigger in size means weaker attraction, and therefore less energy is needed to break the attraction. Okay, all right. Next question would be arrange ionic compound below in order of increasing melting point. Okay, we should start from the lowest to the highest. Justify your answer. Okay, let's have Azri for this.
My answer is
Okay,
KBr, MgF2, CaCl2.
GF2, CaCl2. Okay, so this is increasing. So this is based on Azri's answer, increasing melting point. Okay, all right. So what would be your reason for this, Azri?
Because the attraction is stronger.
Which one has a stronger attraction?
CaCl.
CaCl. Why is it stronger? Why is it stronger? Are you comparing this to, you must compare, okay? You must discuss in terms of KBR, why is it having the lowest melting point, and why CaCl2 having the highest melting point. So you're going to compare in terms of CaCl2, MgF2, and KBR. Okay, it should be comprehensive. Your answer should cater all of that. Okay, why KBR is the lowest is due to, okay, the melting point they relate dengan lattice energy. Basically, the reasoning should be the same lah. Okay, KBR, why is it the lowest? It's due to
because it has the lowest lattice energy.
lowest lattice energy. Okay, all right. But due to, again, macam mana, how do you decide that this KBR has the lowest lattice energy? There must be reason for that, right? So macam mana you dapat KBR has the lowest energy?
The charge.
Yes, okay, it's because of the charge. Okay, the obvious one would be for the charge lah. Okay, so this is positive 1, this is negative 1, this is negative 1. For MgF2 and CaCl2, betul ke ni? Ni macam tak betul je ni. Sekejap. Okay, MgF2, positive 2, this is negative 1. Okay, this is positive 2, this is negative 1. Okay, so the obvious one would be KBR would be the one that has the lowest melting point because of the charge. The ionic charge is the lowest. That is why KBR has the lowest melting point. But how about MgF2 dengan CaCl2? Are you sure that CaCl2 has the highest melting point? Have you checked the magnesium location and the calcium in a group? In terms of size, okay, in terms of this, we cannot compare them based on the charge only. Kita kena consider the size. Okay, we have to consider the size. Azri?
Terbalik madam.
Okay. So yang mana yang terbalik? KBR ke yang terbalik?
Mg dengan Cl.
Okay, so it should be CaCl2 and then we have MgF2. Okay, alright. So for these two, kita nak compare in terms of apa?
Size.
Yes.
In a group.
Okay, alright. So it should be based on the size. Going down the row because they have the same charge. Okay, this is positive 2, this is negative 1, this is positive 2, this is negative 1. So charge is not significant. Okay, charge is no longer the solid reason why the melting point for magnesium fluoride is the highest. Okay, so we need to discuss in terms of the size. Magnesium is located above calcium in a group. That means magnesium has smaller size. Smaller size, the attraction is stronger, therefore the lattice energy will be higher. Okay, when the lattice energy is higher, that means the melting point should be higher. Okay, alright. Kena ada cukup bila kita tanya banyak soalan tu, maksudnya your answer is not comprehensive enough. Dia tak complete dekat situ. Dia ada missing point dekat situ. Okay? You kena prepare your answer sampai examiners terdiam. All the key points are there. Okay? Alright. So this is the answer. Okay? KBr has the smallest, CaCl2 has the same ionic charge as MgF2 but has bigger ionic size. Okay, so this is how you should prepare your answer. You should have all the keywords ataupun the key point in your answer. Okay, alright, so moving on. Okay, so we are done with that. Next, covalent bond. As you can see, we have a lot of learning objective for covalent bond only. Okay, make sure that you tick all of this. Okay, you cover all of this once you have completed this checkpoint. Okay, what is covalent bond? Covalent bond is a chemical bond formed by sharing valence pair of electron between two atoms and held by electrostatic attraction between bonding electron and nuclei. Okay, all right, so in previous we have ionic bond. So ionic bond is based on the transfer of electron. Okay, again, why do they need to transfer the electron? Because they want to achieve the octet configuration. Okay, alternative to ionic bond, we also have covalent bond. So covalent bond is also a method ataupun a way for atoms to achieve octet configuration. Okay, so covalent is formed by sharing the electron, by sharing the valence pair of electron between the two atoms. Okay, so they share the electron in order for both of them achieve the octet configuration. Okay, so that shared electron is held by electrostatic attraction. Okay, because we have nuclei and the electron. So that is called electrostatic. We have positive and negative. Positive come from the nuclei, the nucleus itself. Okay, we have two nucleus and the electron shared, okay, is negatively charged. So opposite charge attracts. Okay, so the shared electron would then count toward each atom's octet. Octet rule apply. Okay, so atom can achieve an octet of valence electron by sharing their valence electron with other atom, except for hydrogen. Okay, it achieves duplet. Hydrogen want to become like helium. So duplet is also considered as stable configuration other than octet. Okay, all right. So bonding pairs and lone pair. So what is bonding pair and what is lone pair? Okay, so electrons that are shared by atoms are called bonding pair. So obviously, okay, the electrons that are shared by atoms, those are called bonding pairs. Electrons that are not shared by atom but belong to a particular atom are called lone pair or non-bonding pair. Okay, look at example we have here. So this is hydrogen chloride. Okay, so hydrogen requires one electron, Cl requires one electron in order to achieve octet and duplet configuration. Okay, all right, so one of the way is in order to achieve the octet configuration is by sharing their electron. Okay, all right, so bila dia share the electron, this is what we call bonding pair. Okay, so one pair is consists of two electrons. Bila dia cakap pair, you kena alert dekat situ bonding pair electron. Maksudnya one pair is consists of electron. Kalau dia cakap bonding electrons, that means without the pairing. Faham? So don't get confused. Kalau dia highlightkan pair, that means one pair should consist of 2 electron. If the question did not mention anything about pair, dia kata bonding electrons. That means bonding electrons ada 2. Okay, bonding pair means for this one, kita ada 1 pair which consists of 2 electrons. Kalau dia cakap bonding electron, that means we have 2 electrons. Okay, so be alert, be aware of apa yang dia tanya, whether the question is asking for pair or electron. Okay, alright, so this is bonding pair. Okay, ataupun kita boleh nampak using the Lewis dot symbol. So this is bonding pair. Okay, so we have one come from the hydrogen, the other one come from Cl. Okay, so this is bonding pair. The rest are all lone pair. Nampak tak yang ni? Hydrogen dah tak ada lah. Hydrogen memang ada 1 elektron saja kan. Alright, so the rest are all lone pair. So this lone pair ataupun non-bonding pair. Lone pair is electron that is not involved in the bonding. Okay, so this lone pair ataupun non-bonding pair belongs to one owner saja. Yang ni dia ada 2 owner. Bonding pair dia ada 2 owner. Dia ada hydrogen and Cl. Okay, but lone pair is only belongs to one atom sahaja. Dia punya owner hanya seorang saja. In this case would be chlorine. Okay, alright. So we have 3 lone pair, but in terms of non-bonding electron, we would the number is 6. Okay, 6 lone pair electron. Okay, 6 lone pair electron because we are highlighting the electron. Yang ni kita highlightkan the pair. Okay, that consists of 6 electron. Sorry, 6 electron. Okay.
Madam.
Yep.
Kenapa dekat yang belah kiri tu H tu, kenapa untuk Lewis dot symbol dia tak letak H dot 1 kat situ?
Dekat sini.
Mana
Mana boleh, dia kat hydrogen kan ada 1 je elektron.
Oh, so tak payah letak lah.
Tak baik. You may use apa garis ni, okay, this line ataupun you may use the Lewis dot symbol. Okay? Yang this one. Okay. Mana tadi? This one, ini hydrogen punya. This one belongs to Cl. Okay, remember hydrogen only has 1 electron sahaja. Okay, so kalau ini dah digunakan, katakanlah this one kan, bila dia share dekat situ, okay, dia share di sini. Okay, so this one hydrogen punya, this one Cl punya, sorry. Okay, so jangan disobey lah dia punya original electrons je. So hydrogen has only 1 electron. Chlorine on the other hand has 7 electron, betul tak? So 2, 4, 6, 7. 7 electron. Hydrogen has 1 electron. So when they share electrons, so hydrogen now has 2 electron. Okay, Cl pun sama, they have Cl has 8 electrons when they start sharing. Okay, alright. Okay, so bonding pairs and lone pair, generally elements follow certain common bonding patterns. Okay, so normally carbon has 4 bonds. Okay, perasan tak bila kita draw hydrocarbon, normally carbon would have 4 bonds with no lone pairs. Okay, so this is how carbon looks like. So carbon normally has no lone pair. Okay, oxygen normally would have 2 bonds and 2 lone pairs. Okay, and 2 lone pairs. Beryllium, okay, has 2 bonds. There's no beryllium here. Okay, so beryllium has 2 bonds without lone pair. Okay, nitrogen on the other hand has 3 bonds. Okay, normally nitrogen would form 3 bonds with 1 lone pair. Okay, hydrogen and halogen normally would form 1 bond only. Okay, the rest are all lone pair. Hydrogen tak ada, obviously hydrogen there's no lone pair lah. Okay, hydrogen has no lone pair. Halogen has 3 lone pair. 3 lone pair. Okay, which equivalent to 6 electron. Boron has 3 bonds. Okay, can have 3 bonds without lone pair. This is normal atau common bonding pattern for common atoms. Okay, so carbon, fluorine, chlorine, nitrogen, oxygen, those are common atoms that can be found mostly lah, okay, in compound, right? Okay. Right, so we have several types of bonds. So we have 3 types of bond. We have single covalent bond, double covalent bond, triple covalent bond. So single covalent bond means the 2 atoms share 1 pair of electrons sahaja. Okay, so that is called single covalent bond. For example, we have fluorine here, kan? So fluorine atom requires 1 electron in order to achieve octet. So they can share with one another, okay, and then they can form this atom. This molecule. So this is what we call fluorine molecule, okay, F2 molecule. So this is what we call diatomic molecule, okay. So they share 1 electron each to form the single covalent bond. We also have H2O. Okay, so this is simple molecule with simple covalent bond. They involve only 2 atoms. We can also have single bond for H2O. Example, okay, H2O. So hydrogen, okay, requires 1 more, and then oxygen on the other hand requires 2 more electron. So how does oxygen achieve octet electron configuration? By sharing the electron with 2 hydrogen. Okay, with 2 hydrogen. Okay, so hydrogen, this one achieve octet, ni pun octet, this also achieve octet. Okay, so this, when they share the electron, okay, this is the single covalent bond. Okay, alright.
Madam,
Yep.
untuk yang tadi single covalent bond tu dia tak kisah same element ataupun different element.
Tak kisah, as long as dia ni CH4.
So kalau untuk in case lah, kalau H dengan H boleh ke nak jadikan H2 je? Is it
Boleh.
single bond? Dia single bond jugalah?
Ya. Okay, single bond dia punya basic concept dia share 1 electron each. Okay, the atoms involved in the bonding, they should share only 1 electron each. Itu dia punya konsep for single bond. Okay, regardless lah. Contohnya NH3, okay, NH3. Okay, so this is also single bond. Okay, so later we will learn on how to draw the Lewis structure for covalent bond. Okay, covalent compound. Okay, alright. Tu contoh je lah, dia bagi sikit kan. Dia bagi satu yang dalam keadaan simple molecule, the other one ni dia involve more than 2 atoms. Okay, molecules involve more than 1 type of atom. Okay, so we have H2O. Okay, alright. So double covalent bond. Okay, so dia share 4 electrons dekat situ. Okay, for example, oxygen. Okay, so oxygen is considered as a double covalent bond. Why? Because these 2 atoms share 2 electron each. Okay, so oxygen ni share 2 electron, this one share 2 electron. Okay, alright. So in total, kira 2, 4, 6, 8. So oxygen, the first oxygen has 8 electron, which is octet. So the second oxygen also has 2, 4, 6 and 8. So 8 electron. Okay, alright. So dia share tu because they want to achieve the octet configuration. Cuma macam mana they share. Okay, how they go about in terms of sharing. Sometimes they share only 2 electrons saja. Sometimes they may share 4 electrons. Okay, sometimes they may share 6 electron. Kenapa dia share berbeza-beza? Because dia kena achieve the octet configuration. Okay. Triple, okay, so we have triple covalent bond. So triple means they share 6 electron dekat situ. Okay, example, we have nitrogen dekat situ. Okay, each nitrogen requires 3 more electron in order to achieve octet configuration. Okay, so they need to share 6 electron in order to achieve the octet configuration. Cuba kira bila dia share 3 electron, okay, ada 3 pair. Seorang share 3 electron, so means kalau kita ada 2, 6 electrons involved. Okay, so kira for this nitrogen, the first nitrogen, it has 2, 4, 6, 8 electron. Okay, so dia ada 8 electron. That means it's octet lah. Okay, same goes to this nitrogen. 1, 2, 3, 4. So there are 4 pairs of electron involved. Okay, which is 1 datang daripada lone pair, 3 from another 3 more come from the bonding pair. So in total there are 8 electrons dekat situ. So still dia adalah octet. Okay, with 3 bonding pairs ataupun triple covalent bond. Okay, alright. Okay, so Lewis theory predicts that atom will be more stable when they achieve octet configuration. Okay, so everybody want to achieve octet configuration. However, we have exceptions to that. Okay, tapi later kita akan cover for that. Okay, normally most of the atoms in the periodic table, they want to achieve the octet configuration. Okay, all right, so let's check for nitrogen trifluoride. Okay, so this is nitrogen trifluoride molecular compound. As you can see, all of them achieve octet configuration. Okay, cuba check for fluorine, for each fluorine. Okay, so each fluorine has 8 electron. Same goes to this fluorine also. Dia ada 2, 4, 6, 8. So 8 electron. Ini pun sama, 2, 4, 6, 8 electron. Okay, so nitrogen pun also has 8 electron. Cuba kira 1, 2, 3. So 3 maksudnya 3 bonding pairs equivalent to 6 electron. So we have 1 lone pair for nitrogen. 6 tadi tambah 2 is equal to 8 electron. Okay, so all of the atoms in the molecule are octet. Okay, so Lewis theory predicts that atom will be more stable when they achieve octet configuration. Okay, all right. So we have steps in converting a molecular formula into a Lewis structure. This is a very, 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 very important step. Okay, it's like in topic 1 last time. Okay, we learned on how to write the chemical formula. Remember, before we could go further, before we could prepare a balance equation and then later on calculate. Okay, for the calculation. So you need to have your chemical formula correct. Okay, that is for topic 1. For topic 2, topic 3, the most important step is Lewis structure. Okay, you have to have your Lewis structure correct ataupun the right Lewis structure. If not, the following question lepas ni will be salah. Okay, definitely will be salah because it is affected by your wrong ataupun false Lewis structure. So ini punya part, this step is very important for you to really understand, to really be able to draw the correct Lewis structure. Okay, alright, so dia ada steps je dekat sini. Kita akan go one by one. Okay, step 1, you have to total up the number of valence electron for each atom. Okay, let's say dia bagi tadi apa, NF3 just now kan. Okay, so soalan tanya, draw the Lewis structure for NF3. Bila draw the Lewis structure, that means you have to have all the electron visible. Okay, kena tunjuk each of the electron in the molecule. So we're going to start with, you have to total up the number of valence electron for each atom. You have to total up the nitrogen, fluorine, we have 3 fluorine, so total up all the valence electron. Okay, and then from there, we're going to choose the atom with lowest electronegativity as the central atom. Kita kena decide which of these two atom, okay, will become the central. Central is very important. It's like the mother, okay? Dia yang pegang all the terminal atom tu. So so we will choose based on electronegativity. So remember electronegativity in topic 2, dia punya trend dia across the period, the electronegativity increases. Okay? So in order to become central atom, the atom should have lower electronegativity. We go for lower electronegativity. Okay? And then nitrogen and fluorine. So which one has the lowest electronegativity, guys?
Nitrogen.
Yes. Okay, so nitrogen has lower electronegativity. No wonder lah tadi, yang drawing tadi, yang Lewis structure tadi, nitrogen is the central. Okay, and then place other atom around the central atom as terminal atoms. Okay, as terminal atoms. So the rest will be dia punya terminal lah. Terminal mean tepi. Okay, dia punya surrounding atom. Okay, terminal or surrounding atoms. And then draw single bond, okay, to connect the central and the terminal atom. And then we have to subtract with 2 electrons for each bond. So because each bond consists of 2 electrons. Later we'll subtract. Okay, distribute the electron and give each atom a full octet. Okay, 2 electron for hydrogen. Don't forget that hydrogen only requires 2 electrons only. Jangan octetkan dia, jangan jadikan dia 8 pula, ya. Yeah? And then lastly, if the central atom does not have a full octet, that means multiple bond is or are present. We have to consider for multiple bond. Because lastly kita kena check each one of the atom in the molecule should achieve octet. Last kali punya step. Kalau dia tak octet, kita discover, oh, this central is yet to achieve octet. Dia belum cukup lagi the electron. That means we have to consider for multiple bond. Double bond or triple bond. Okay? Alright. So, ni dia punya step lah for your reference. Okay? So, let's okay, kita start from the beginning. Alright? Okay, saya tambah kertas kosong dekat sini so that we can kita boleh start from the beginning. CF2Cl2. Okay? Alright, so we're gonna start. How do we draw CF2Cl2? Okay? Alright, so kita totalkan. Okay, I prefer to start from determining the central first. We determine the central first. Okay, alright, so central, in order to determine the central atom, we should be based on the electronegativity. So we have chlorine, and Cl. So between these 3 atoms, which one has lower electronegativity?
Madam, tu chlorine ke carbon?
Chlorine. CFCl. CF2Cl2. Kan? CF2Cl2. Okay? Carbon lah, carbon. So we have 3 atoms here. So which one has the lowest electronegativity, guys?
Carbon.
Okay. So carbon has the lowest electronegativity. That means carbon should be placed as the central. Okay. So carbon should be placed as the central. So kita placement okay. Carbon should be placed as the central. Okay. So kita pun the rest kita place sebagai surrounding. Lebih pula. There should be 2 Cl. Okay. Cl. Okay. So kita connectkan dia orang siap-siap. Sebab after all nanti kita kena connectkan kan. So kita decide first step. Kita modify sikit lah from the other, from the steps that we have just now. Okay, but if you feel that you want to go for the step shown just now, okay, go ahead, tak ada masalah. Okay, alright. Kita dah set and then we go for calculation. Okay, so first step, decide for the central atom, and then bila dah decide for the central atom, the rest will become terminal lah. Cl and fluorine will become terminal. Okay, so kalau dia biarkan terapung-apung macam ni, you biarkan terapung-apung macam ni, at the end of the day, you still juga kena connect them, betul tak? Kena connect. Connect means you have to have bonding pair lah, ataupun single covalent bond dekat situ. Ni bond lah ni, this is what we call bond. Okay, at the end of the day, you still have to connect them. So that's why saya letak awal-awal dekat situ. Okay, alright. So kita nak calculate total of electron, total of valence electrons. That means kita kena totalkan carbon, how many valence electron for carbon, guys? How many?
4.
Yes. Okay, jangan confuse jangan ingat 6 pula. 6 tu dia punya proton number, dia punya mass number. Do not get confused with mass number. So carbon come from group 14, that means it has 4 electron. So how many carbon do we have here? So we only have 1 carbon. Okay, how about fluorine? Kita kena totalkan all the valence electron. Okay, so fluorine has 7 electrons. So we have to times with 2 because it has 2 fluorine atom. So in total we have 14 electron. Okay. And then we have 2 chlorine there. So we have 2 chlorines. Same goes with chlorine, we have to multiply with 2. So chlorine has 7 electrons times with 2. Okay, we have 14 electron also. Now kita totalkan dia. So how many electrons we have here? 28, 32. Is it? Betul ke? Ini paling penting kalau you salah kira nanti you akan pelik, you akan dapat number of electron pelik-pelik dekat situ. Okay, so it should be 32 electron. So all of this 32 electron, okay, must be used. Dia mesti digunakan. Okay, later we should get 0. That means all the electrons has been given ataupun has been fully used. Okay, dia dah diberikan, dia dah distribute, they must be distributed, okay, into the into the molecule lah. Okay, is either fluorine dapat ke, carbon dapat ke, later on kita akan go for that. Tapi kita nak total the valence electron dulu. Okay, so all these 32 electron must be digunakan sepenuhnya, completely used up. Okay, alright. So next step. First kali kita nak kena minus dengan apa? We have to minus with the bond. Sebab bond kena form dulu, betul tak? So 32 electron is the total electron. Next kita kena minus with the bonding electron. Okay, with the bonding pairs. So how many bonding pairs electron we have here? So we have 1, 2, 3, 4 bond, which equivalent to 8 electrons. So minus with 8 electron dekat situ. So this is for bonding electron. So 2, kelakar nak tolak pakai macam ni kan. 12 tak 8 apa? 4 24. Okay. Alright, so we have 24 electron left. Okay. Alright, so next will be, dia punya step dia adalah to distribute this electron. Okay, kita dah ada bond. Next, kita kena distribute to the terminal atom. Kita kena octetkan the terminal atom. Okay, we have to octet to make sure that all the terminal atoms must achieve octet. Okay, there's no hydrogen, that means tak ada duplet lah. So all of them must achieve octet. Okay, alright, so we have to distribute all these 24 electron. Kita nak octetkan dia. Okay, we go one by one lah. Okay, so fluorine kena ada 8. Okay, so each one kena ada 6 lah. Okay, alright, so 1, 2, 3, 4, 5, 6. Total ni jadi 8. Okay, so 1, 2, 3, 4, 5, 6. Total 2 more electron come from bonding electron. So we have 8 electron for this fluorine. 1, 2, 3, 4, 5, 6. Okay, 6 yang kita distribute plus these 2 electron. So in total, this fluorine has 8 electron. So each of the atom, each of the terminal atoms is now already octet. So how many electrons we have used so far? We have used 6 times 4, kita dah pakai 24 elektron dekat situ. So ada baki tak? Tak ada. That means all the electrons have been used. Kita dah guna. Dia kena dapat 0. You have to get 0. Kalau you ada baki dekat situ, you kena settlekan supaya dia dapat 0. Okay? Alright, so this is the Lewis structure of CF2Cl2.
Madam,
Yep.
kalau in case kita ada baki, kita kena add dekat central atom lah.
Yeah.
Okay.
Okay, itu contoh lain lah. Ini kita contoh for yang maksudnya kita check, okay, lastly kita check, okay, we have to check for each of the atom, dia mesti achieve octet, including the central, okay. Okay, let's check. Fluorine, the first fluorine is octet. 2, 4, 6 plus these 2 is equal to 8. Okay, how about this fluorine is also octet, this chlorine, octet, and this last chlorine is also octet. Don't forget the carbon, the central is also octet. 2 plus 2 plus 2 plus 2. Okay, so we have 8 electron for carbon. So everybody now is octet. So this is the Lewis structure for CF2Cl2. Okay, alright. So itulah step dia. Okay, maybe kita boleh try lagi NF3, so nitrogen trifluoride. Okay, so okay, let's start from the beginning. Okay, kita start lagi sekali, cuba banyak kali so that you get exposed to how dia punya steps tu lah. NF3. Okay, so we're gonna decide N dengan F, nitrogen has the lowest electronegativity compared to fluorine. That means nitrogen should be placed at the central. Okay, right. So kita pun place siap-siap lah. Begini. Ini dia punya rangka. This is the skeleton lah. Okay, right. So this is how the placement of the atom. Nitrogen should be at the central, as the central atom. The rest should become terminal. All the fluorine should become terminal. Fluorine tak sesuai jadi central. Okay, dia tak sesuai jadi central sebab fluorine requires only one more electron. Normally yang duduk dekat tengah tu yang boleh form as many bond as possible. Okay,
Madam,
fluorine.
Sorry. Orientation untuk fluorine tu tak kisah kan, atas bawah?
Tak kisah. Sebab kita belum belajar dia punya geometry lagi. Later on kita akan belajar the geometry. So that's why you need to have your Lewis structure correct first. Okay, sebab soalan banyak based on Lewis structure kemudian. So that's why if you got your Lewis structure wrong, that means the rest kita boleh kata salah lah. Okay, most likely for you to get it wrong too. Okay, so nitrogen, fluorine. So this is the placement of the atom. Next step, okay, kita go for this one. This one will be the first one. The second step is to total all the valence electron. Okay, all right. So nitrogen, we have 5 electrons. So how do we know this? Because nitrogen come from group 15. That means it has 5 electrons. Fluorine has 7 electrons. So we have 3 fluorine atom, right? So times with 3. So it is 21 electron. When we total up the electrons, we got 26 electrons there. So we have to make sure all these 26 electrons must be distributed, okay, among the atoms in the molecule. Okay, 26 electron. First step, kita kena minus the bonding electron. Dia follow step, dia kena follow step. Kena start dengan bonding electron dulu. Kita remove the electron for bonding electron dulu. Okay, so how many bondings, how many bonds we have here? So we have 3.
So 6
3
electron.
is equal to 6 electron. Okay, all right, so 6 electron. We use 6 electrons, so minus, so this one should come from bonding electron. So we have 20 electron extra. Okay, so these 20 electrons next will be distributed to the terminal atoms. Kena follow step tu. Dia tak boleh terminal atom dulu baru buang bonding, tak boleh. Dia kena bonding, then only you go for terminal atom. Okay, alright, kita octetkan the terminal atom. So how many do we use? Okay, so we use 6 for each of the fluorine. Okay, because 6 and then plus 2, it is equal to 8. Okay, so this fluorine is now octet. So 2. Okay, ini sepatutnya dekat bawah dia. Okay, jangan buat macam saya ni Okay, 1, 2, 3, 4, 5, 6. So in total, 6 times 3, okay, we have 18 electron. We have used 18 electron out of 20 electron here. Okay, so this is for the terminal atom ataupun terminal electron lah, because we are talking about electron kan, so terminal electron. Okay, so we have 2 more electrons dekat situ. Kita ada 2 lagi baki dekat situ. Okay, next, if we have extra electron, macam tadi kan we don't have extra kan, dia terus 0 kan, then tak apalah. Okay, for this one, we have to make sure that the electron, okay, at the end of the day should be 0. Okay, should be 0. Okay, so these 2 electron will be distributed to the central. Okay, like I said, central is like the mother. Normally mother will sacrifice everything kan. So last kali baru dia baru dia dapat that electron. Okay, dia bagi dulu ke anak-anak dia. Okay, so 2 electron will be given to the nitrogen. So we place the nitrogen, we place the electron, okay, the 2 electron to nitrogen, on nitrogen. Okay, so this is how it looks like. Okay, alright, so now kita dah guna the 2 electron minus, so this one should come from central electron, okay, ataupun central atom. Okay, central lah senang cerita. Okay, 0. Kita nak 0 ni. Okay, alright, lastly, don't forget to check guys. You have to check, okay. So fluorine, octet. Okay, the first fluorine is now octet. The second fluorine is also octet. The third fluorine is also octet. Okay, how about the nitrogen? We have to check. Okay, so the nitrogen we have 2, 4, 6. Okay, 6 electron that come from 3 bonding pairs, and then 2 electron come from lone pair. 1 lone pair. So in total we have 8 electrons there. That means octet. Okay, so nitrogen is now octet. Okay, faham ke?
Faham?
Hilang. Okay, yeah, question.
Tak faham.
Yeah, you kena faham kan, tak faham tanya, sebab this is very important. This is like the first step for kita ada multiple step ataupun banyak step lepas ni following. Okay, subtopics is all depends on this Lewis structure. If you tak faham Lewis structure, that means you're gonna stuck lah. You akan stuck, confirm you akan stuck from for the following subtopic.
Madam, kalau untuk Lewis structure ni kita punya maximum element combination tu berapa ya?
Tak kisah juga. Dia boleh you mean number of atom ke in a molecule?
Sebab macam tadi kan ada 3, ada 2 kan?
Dia tak kisah. Can be 3, can be 4, sometimes can be 5, it depends. Okay? This sometimes normally we would have satu central je. Sometimes kita boleh ada 2 central atom dekat situ. Contohnya, okay, let's try out this multiple bond. Bila nak form multiple bond tu? Okay, alright. So kan ada the last step tu kita ada if there are not enough electron for the central atom. Okay, imagine bila kita dah kira-kira tiba-tiba central tak cukup pula dia punya electron. That means dia belum octet. So how do we solve that? Okay, that means kita kena consider for multiple bond. If the central atom does not have a full octet, change a lone pair on a surrounding atom into another bonding pair to the central atom, thus forming a multiple bond. Okay, alright. So let's write out this one. Bawa pula dekat sini mana tadi? Sini ya. Okay, kita try this one. Okay, right. Ni yang saya cakap tadi, dia ada 2 lone pair dekat situ. 2 lone pair, 2 central. Okay, alright, kita try placement of the atom. Okay, this is obviously, okay, carbon dengan hydrogen. Obviously hydrogen has the lowest electronegativity, betul tak? Compared to carbon. But hydrogen cannot be the central. Cannot become the central. Dia tak boleh jadi central because it only has 1 electron saja. Okay, this is special. This is only applicable for hydrogen. Even though it has the lowest electronegativity, but it cannot be placed as the central. Okay, alright. So next will be carbon lah. Kalau dah hydrogen tak boleh jadi central, next will be carbon. Okay, so hydrogen is very special. So we have carbon, so we have 2 carbon dekat situ kan. Alright, so that means we have carbon, and then we have carbon. Okay, next will be hydrogen here. Okay, kita try buat equally lah dekat situ. Ini pun ada isu juga. Mungkin ada orang akan tanya, madam, kenapa tak buat macam ni? One. Betul tak? Mungkin ada isu. Okay, dekat sini kita ada cara nak tentukan which one is the best Lewis structure. Is it the first one or the second one? Okay, so obviously second ni bukan lah, tapi macam mana kita determine that? So later we will have formal charge. Okay, alright, so let's just stick with the first Lewis structure. So this is the Lewis structure for C2H2. Okay, alright, so this is kita assign lah sebab dia macam simetri dekat situ kan. So each carbon should get 2 hydrogen. Okay, alright, so kita totalkan the valence electron. So carbon 4 electrons times 2, we have 8 electron. Hydrogen, we have 1 electron times 4, kita ada berapa? 4 electron. Okay, so in total we have 12 electron. Okay, right. Padam dulu ni, saya mak. Okay, so 12 electron kena minus dengan apa dulu? Apa benda nak buat ni? Okay, 12 electron minus dengan bond dulu. Okay, so how many bonds we have here? 1, 2, 3, 4, 5. 5, that means 5 times 2 is equal to 10 electron. Okay, this is bonding electron guys. Minus, kita ada baki 2 electron lagi. Betul tak? Okay, 2 electron ni nak place dekat mana? Okay, next. Kita patut bagi kat terminal, betul tak? Tapi terminal kita kena tengok siapa? Hydrogen. Hydrogen tak perlukan elektron. Hydrogen dah octet dah duplet dah ni sebab dia dah achieve the 2 electrons. Okay, dia dah duplet. So jangan pergi letak dekat hydrogen pula. Remember, hydrogen is special. Dia duplet. Dia bukan macam yang chlorine just now. Dia octet. That's why kita kena octetkan them. Okay, but for hydrogen, we do not have to octetkan. Sebab dia dah already duplet dekat sini. Bila dia form bond, it's already duplet. So, these 2 electrons should be placed at the central. As you can see, we have 2 central. 1, 2. 2 central dekat situ. So, nak place dekat mana? Pecah bagi seorang satu. Don't do that. Jangan pecahkan. Okay, what we are trying to do is to make sure kita kena banyakkan seboleh mungkin atom yang octet. Kalau you place 1 each, dua-dua carbon tak octet. Okay, dua-dua carbon tak octet. Tapi if you place macam ini, both 2 electron to one of the carbon, okay, this carbon is now octet. Betul tak? But this one is yet to octet. Okay, so jangan pergi pandai-pandai bagikan sama rata dekat situ. 1 elektron, 1 elektron. Okay, alright. So kita dah guna the 2 electron. So this 2 electron is given to the central electron. Okay, central atom. That means we have 0. So kita dah settle in terms of the electron. But in terms of the atom, okay, rupa-rupanya this second central is yet to achieve octet. So how do we make sure that all of them should achieve octet and duplet? We form multiple bond. Okay, how do we form multiple bond? So these 2 electron will form another bond between the carbon. So bila dia form bond dekat situ, saya draw balik, so dia akan jadi macam ini. Okay, alright. So now everybody octet. Okay, so ni octet 2, 4, 6, 8. How about the second carbon? 2, 4, 6, 8. So both of them octet. So that is how, kalau kata tak cukup lagi, then you form another bond. So it become triple bond. So this is double bond kan? Kalau dia tak cukup lagi, that means you form another bond. Okay?
Madam, kita kena tunjuk ke yang first step dia transfer?
Tak payah.
Tak payah. Terus
tak
direct lah.
Ya. Sebenarnya nanti Lewis structure nanti, kita nak your Lewis structure. Kita tak nak you punya working ni. Faham tak? Dia macam you kira molar mass lah. Okay, we do not want to know how you calculate your molar mass, but we want the molar mass. Okay, this is not there's no mark for this one. But in order to get the correct Lewis structure, you should have this calculation. Okay, so dia agak apa nama tu, agak kejam lah dekat situ tapi that's just how it is lah. Alright, okay guys, sorry. Okay, 9:59. Thank you everyone for your attention. Okay, don't forget our class on Wednesday. Okay, thank you everyone. Okay, bye.
Thank you, madam.
Thank you,
Madam.
Thank you, madam.
Bye.
Thank you, madam.